Hi, I'm Omkar, and I just wanted to make a video on how to do RAG with Google's AQA model because I just wanted to make a guide for people like me who don't really want to get into specifics and just want to get the code and build apps on it. So yeah, check out my GitHub in the description, and yeah, let's get started. So RAG, or retrieval augmented generation, why do we want to do this? We want an LLM to answer on custom data, and we want to reduce hallucinations. And so we can basically feed it our private custom data and have it answer on that. For step one, you want to input your data into a vector database and chunk it. So for that, we have to create embeddings based on semantic meaning. So what does semantic meaning mean? Basically, it's literally like what something means. So yeah, surprisingly through AI, you're able to turn that into an actual numerical value. And this works for almost any kind of data, images, audio, video transcripts, PDFs, websites, basically anything that can be described or transcribed into text. And that text is turned into an embedding value. Now, I think we may be having multimodal embeddings, but I don't know. For this, we're just going to talk about text. So using transformers, we can create embedding values like transformers like BERT, GPT. They're doing really cool math, like through neural networks, matrix multiplication, nonlinear activation functions, all kinds of cool stuff you can look into. But at a high level, it's basically doing math to create embeddings for that chunk of data based on its semantic meaning. So when I say a chunk of data, that could literally be from a heading to a heading, but chunk sounds, it's exactly as it sounds like. It's a chunk. So transformers basically work by looking at all your data at once, and it's basically going to look at that and it's turning that into an embedding value. So that's a numerical value from 0 to 1 that represents its semantic meaning. So here's a picture of it. It can be done through keywords, but we're using the embeddings. So it basically compares the embeddings value of the inputted query and searches that database for the chunk with a similar value. And this is called similarity search, which is done through math like Euclidean distance and cosine similarity. This picture kind of just shows, and this is just 3 dimensions, but the vector databases have like a lot more. And it's another picture. So I'm just going to give an example. Let's say I just input cats are cool, and the model is going to generate an embedding value for that input. Oh, by the way, sorry, let me go back. So basically when we take all that data, right, we're going to create embeddings values and store that, right? And we got to do that before we start using the model. You don't just do that on the fly, you do it before. And once you create that, you're good to go. Those values stay the same, as long as your data is the same. And it basically generates embeddings value whenever you put an input. So when you're actually using it, it generates an embedding value. And it does a similarity search for that value. So I was talking about that earlier. But basically, it's going to find some sort of data that's closest to the input. So it's going to find something related to cats, maybe. If maybe my data is on like different kinds of animals, it'll find the chunk that's closest to cats, because remember, it generated a numerical value for all of my data, right? And it's creating a numerical value for my input that I just inputted into the chatbot, whatever. And it's going to compare these and see like, oh yeah, this user's input is closest to this chunk about cats. And it's going to load up that chunk and kind of input it into the prompt so it has better context and can answer with fewer hallucinations. If I'm in ChatGPT and I input some sort of article or data into it, then and I ask it to answer on that article, then it's more likely going to be like not hallucinating because I fed it that article. So in this way, it's basically pulling relevant data. So hybrid RAG, I think that's what we're doing here. But basically it's RAG plus a general model. What we're doing is, so Google AQA model is really cool because it gives a thing called answerable probability. And I don't know if this is in other ones too, but they have a thing called answerable probability, which basically is kind of like how confident it is based on the data, which is nice because then you can say, oh, if it's not that confident, you basically ask a general model, like you ask Gemini instead of asking this AQA model. So or you could give an error message, but yeah, that's hybrid RAG. You can look into that. But all right, time to jump into the code. So now I'm just gonna explain the code, and starts from the bottom here. So what we're doing is I just defined a folder where we're actually putting the data, and what the data is it's PDFs. By the way, let me just go ahead and explain the options to you. You can either do long context, which is, you're gonna have better accuracy on your data, and it's gonna be like, yeah, it's gonna have like all of that data collectively, but it's also gonna cost more for inference. I think RAG is still gonna be better for data security, and that's why Google is still offering the AQA model. This code is just for PDFs, and so that's good if you already have a lot of structured data in PDFs, but there are also a lot of services out there to take websites and on batches turn them into PDFs, or take unstructured data and turn that into PDFs. And all you need to do is just put that in this folder. And I think you can use this code out of the box, but if that's not the case, if you want to do something that's not hybrid RAG, because you don't actually have to use the AQA model. You can just use the AQA model to retrieve the context, like retrieve whatever data you need, and then use Gemini or GPT-4o, whatever, to answer based on that data. And also you don't have to use Google's model. You can use any RAG model out there. But I'm just showing you this as an example because I like it to have all of my cloud expenses and all of that in Google Cloud. And Google has amazing support, and so yeah. So let's actually hop into the code. So let's say all your PDFs are in data. I don't have any now, but basically what it's doing is it's gonna look at all of those that are PDFs, and what it's gonna do is it's gonna generate embeddings for all of those. So let's go to that function. This is a function that processes it. And so what it's doing is it's going to create a corpus if you don't already have one. And by the way, I know it's the second time I've said that. You're going to need what's called a service account from Google Cloud if you're using Google AQA model. And whatever service you use, you're going to need authentication. Whenever you run this Python script, it's basically going to take the credentials from that service account. So you can watch any YouTube video, but it shouldn't be too hard to get that service account. It's just a JSON file. You drag it in there, make sure it's like right there, and yeah. And so once it has that service account, it's going to create a corpus under that. And so it's going to generate embeddings for that, like we talked about in like the vector space and all that. So what it's going to do is it's going to create each individual PDF is what's called a document, and the corpus can have 10,000 documents. And so it's going to define like each source and create a document based on that. So then it's going to split that document into chunks, and let's go to the create chunks folder, because the rest of them are pretty self-explanatory. But create chunks, you actually may want to adjust this, because the better chunks you have, and what a chunk is, it's literally what it sounds like. It's just like a block of text. But the more precise your block of text is, the better you chunk it, the better responses you can get. Right now, this is how it splits it. It just does it based on token count. So you want to maybe do this a better way. But yeah, just check the create chunks function. So then once it actually has those chunks, it's going to go in and actually make the embeddings based on those. And once you got that, it's just going to output it into an embeddings.json, which you'll see it'll save here. When you run the script, all you got to do is just run the script once you have your PDFs in and you have your service account. And yeah.